Assalamu alaikum guys. Here we are going to start with our introductory lecture of Fluid Mechanics 1. That subject holds the contact hours 3 plus 3 and credit hours 3 plus 1. 3 is for the theoretical part and 1 is for the lab part. In introduction of the fluid mechanics, we must know first about the fluid and the mechanics separately. That mechanics is the branch of the physical science that deals with both stationary and the moving bodies under the influence of the forces. Either your body is moving or at rest. If the force is going to be applied on any object, it is going to resist against that applied forces. This resistance in terms of stresses is going to be determined and going to be analyzed, and then that particular object can be designed for the particular structure. So it means that if you are going to be analyze or design any kind of the structure that is going to be of solid or the fluid, so you must know about its mechanics first, because all of the structures are going to carry the loads in the form of forces or pressures. So if we will discuss about the fluid, then it is a substance. Any substance in the liquid or the gas phase is referred to as a fluid. Solid is the second category that you are going to be study in the mechanics of solids. A fluid deforms continuously under the influence of the shear stresses, no matter how small it is. Now we are going to discuss about the fluid mechanics. What is a fluid mechanics? Fluid mechanics is defined as the science that deals with the behavior of fluid at rest or in motion. So whether your fluid is in rest or in motion, gas or the liquid, if the force is going to be applied on that particular fluid, then what is the behavior or response of that particular fluid under the action of the forces, that we are going to be discussing the fluid mechanics. The basic principles, the empirical equations, all of the basic rules of the fluid mechanics we will discuss in this particular subject. So before starting with the subject, we must know about the branches of the fluid mechanics. The study of the fluid at rest is called fluid statistics. The study of the fluid in motion where pressure forces are not considered is called fluid kinematics. And if the pressure forces are also considered for the fluid in motion, that branch is called fluid dynamics. So in different chapters with the different topics, we will study all of these three branches of the fluid mechanics and related theories and principles. Like for the fluid statics, if your body, gas or the liquid, if it will be at rest without the application of the external force. And on the other hand, if it is in motion and again without applying the external force, then how it is going to be behaved or respond. And if the body is in motion also along with the applied forces or the pressure, then how it is going to be respond, we will discuss in fluid dynamics. So all of these branches are going to be cover actually your fluid mechanics one whole of the subject and the course contents. And the next slide we will discuss about the application areas of the fluid mechanics as in general, not specifically the civil engineer. In the next slides we will discuss that as a particularly civil engineer, how you are going to be deal with the fluid mechanics as an application in the field. And but as in general, the natural flows and the weathers in the first figure in the left hand side top, you can see that if the natural environment be there, so your gas and the liquids are be a part, you can see can be a part of it. And you must any engineer, if it is involved with the environmental or any other one, he must know about the behavior of the gas or the liquid in the natural conditions. Aircrafts and the spacecrafts, the next one, it is also going to be deal with the gas as a fluid. So how it is going to be interacting, how your solid object is going to be moved through the fluid, and how it is going to be behaved and respond under the action of these particular forces. So this must be known to us. And the human body, it is a combination of the fluid or the blood that is running through the body. It is going to give you a best example of the fluid mechanics. Then boats floating over the sea or ocean, wind turbines, those are going to be installed within the water or at on the land, but those are going to be worked, their working principle is that through wind those are going to be worked, their turbines are going to be worked with the help of winds blowing over there in that particular area. So if the principle of the fluid, mean wind, the gas, is known to you, all of the rules and the basic principles and its action under the applied forces are going to be known to you, then only you can design a wind turbine. And you're in the next figure, you can in the picture you can see the piping and the plumbing system. That's very obvious. The water is going to be running through the plumbing system and the sewage system also. All of those are closed pipes. So again, we are going to be discuss in the later slides, coming slides, about the course content. So in the course contents, you will see that water may be or the liquid may be flow through the open channels, or it may be going to be flow in the closed pipes. So in both of the cases, its rules and its basic principles will be different. We are going to be have a different equations to determine its flows and its other characteristics, physical characteristics. So in this way, if the water is going to be have a water supply system, plumbing system, the sanitation system, in both of the cases, the water, or mean to say the fluid, is going to be passed, going to be flow through these pipes. Then you have industrial application. So any kind of the other type of the fluid or the gases may be having interaction with a certain type of the industrial applications. Now in this slide, we will discuss particularly about the civil engineering field. As in civil engineer, how you are going to be have an interaction with the fluid and correspondingly mechanics, rules of mechanics. So if you are going to be, the first one is the sea and river flood defenses. If the flood is going to be there, river flow be there, sea flow, you can say the water that is flowing within the sea, that and within the rivers, for that you must know about its conditions, that how it is going to be act. And secondly, the water distribution, I have told you about the water plumbing system or the sanitation system. For both types, the network of the pipes be there. These networks need to be designed depending upon the water flowing through the pipes. So if you are familiar with the rules and all of the behavior, the mechanics of this fluid flowing within the pipes, then only you can design the water supply and sewerage system. Then next one is the hydraulic design of the water. Next one is the hydraulic design of water. This hydraulic design of the water, the sewage treatment works, that is going to be discussed with the turbines or pumps. It is also written over there, dams and irrigation. Okay, dams are, you are familiar with that. Those are the water retaining structures in which you are going to be hold the water, and we are going to be save the water in the lakes or in the reservoirs. And further, this energy of the water is going to be used to run the turbines and produce the electricity. So similarly, the pumps and turbines. Pumps are used to extract the water, groundwater from the groundwater tables, and turbines are used to produce the electricity by the mechanical energy of the water. And the last one is the water retaining structures. Your overhead water tanks, and also you can say your underground retaining structures. So wherever the water is going to be retained within the structures, those particular structures are needed to be designed depending upon the behavior of a response or mechanics of the fluid that is retained within that particular structure. So in the figures, you can see the left bottom one is going to show you the turbines installed within a power station of any you can say electricity production system. And on the other side, you can see the irrigation system. Okay, and on the rightmost side, bottom side, you can see this figure that is going to show you groundwater flow. The water is going to be retained within the soil in the form of groundwater tables, and that must be going to be extracted by the pumps, and it is going to be used for the our daily purpose. If you're going to continue with the application of the fluid mechanics, then also we have the structures, concrete or the steel structures. Those are having contact with the fluid. Specifically the bridges. The bridges are going to be having the piers, mean the columns, the vertical columns on which the main bridge slab deck is going to be resting. These piers and their foundations are also submerged within the water, and that particular water and its mechanics is very important to be studied. And you may have groundwater flows, which is very obvious. Okay, a large amount of the water that is used for the human purpose is from the groundwater flows, and also for the irrigation purpose. So for all of the cases, this water that is flowing within the soil its mechanics must be known to you to design that particular system to supply the water to whole humans and to the crop. Now, in the next slide, we are going to be study about the course outline. You will see the course outlines. Okay, starting from the introduction, these different chapters, then properties of the fluid, fluid statics, fluid kinematics, hydrodynamics, or the fluid dynamics. You will see in the third, fourth, and fifth one. These topics or chapters are going to deal the three branches of the fluid mechanics actually. Sixth one is the flow measurement. Seventh is the steady flow through pipes. Eighth one is the uniform flow in open channels. And I have told you that we must know about the flow through the pipes and flow through the open channel. So for both of the cases, different types of the rules and the principles are there, and we will study all of those one by one. Next slide is going to cover the detailed topics. Those are going to be we are going to be study under the umbrella of certain chapters. So here the details are given. So we will discuss one by one. First of all, we are doing the introduction chapter, then we will start the physical properties of the fluid inshallah in the next week, and then the fluid statics in one by one. And under these chapters we are going to be study these different topics. So you can see by yourself. The next slide is also going to show you the 5th, 6th, 7th, 8th topics and chapters and the topics underneath. Now the next slide is going to cover the course learning outcomes. You can see that these course learning outcomes are 6 actually. This effective domain, last one is about the effective domain, and the first 5 are going to be related the Bloom taxonomy, that is going to cover the cognitive level. Okay. So, and also it is going to be, you see all of the CLOs are going to be mapped with the PLOs, and you can see that which PLO is there. Now, what is your outcome based education system? Your OBE system or the outcome based education system is your engineering program is going to be based on this particular system. That is actually going to be have the different domains. You have cognitive domain, you have psychomotor domain, you have affective domain. So if we are going to be assessed you as an engineer about the knowledge, then we can say that we are going to be have a cognitive level. If we are going to assess you guys for your skills, then we can say it is a psychomotor level domain. If we are going to assess your attitude, your ethics, then we can say it is the effective. We are assessing within the effective domain, and there are different levels of these domains one by one, and maybe one, maybe two, depending upon your assessment. If we talk about the PLOs, then we have 12 PLOs in general, and these all PLOs are going to be mapped with the certain CLOs of your specific subjects. And then finally, along with the grades and your within your DMC, another PLO achievement card, or you can say PLO achievement result will be with you. So you must have, along with your grades, you must have achieved all of your PLOs. Now we will discuss about the reference books. Okay, so I will going to email you your all of the reference books in the soft form, and also you may get the hard form from the library or any other sources. So here is the list of the reference books in which we are the first one will be your textbook, Fluid Mechanics with Engineering Application by Robert L. Dufferty. This Dufferty will be your textbook, and along with this book we are going to be take help from the Bensel and also the Douglas by Douglas. It is not given over here, but we will take the reference also from those books. So 3 main books be there. I'm going to email you. Now, if we are going to start with the introduction of the fluid mechanics, so before starting with the physical properties of any fluid, you must know about the states of the matter: solid, liquid, and gas. And out of these 3 phases, the last 2, liquid and gas, we are going to be categorized as a fluid. So if you are going to be have an comparison of solids and the fluids, then it's very simple. At the metric level, at FSC level, and before that, you must familiar with this difference between solid and versus fluids, this comparison, and as general, or within the fluids between gas and the liquid. If we are going to say that gas and liquids are the fluids, then for both of gas and fluids, liquid, you must have a comparison. So if in general we are going to be given comparison, you can enlist the major differences of solid and fluids in this given in this table. The first one about the flow. Okay, solids cannot flow, fluids can flow. Second one are about the closeness of the molecules. The molecules of the solids are very close to each other, while the molecules of the fluids are far away. The third, you can give the comparison about the attractions. The solids have more molecular attractions, but the fluids have relatively less molecular attractions. The fourth one, the major difference you can say about the shape. The solids have a definite shape, but fluids conform to the shape of the container in which those are retained. Then the solids can sustain the shear forces. This is very important point with respect to the mechanics of a particular phase of the object. If it is the solids object is solid, then it can sustain the shear forces, but if it is fluid, it cannot sustain the shear forces. Okay, so either this whether the smaller one or the larger one, so it is going to be flow deformed under the action of the forces. Here you can see in the next slide the all of the molecular formulation of your objects. Like the first one is going to give, the first figure is going to give you a molecular formulation of the solids. The second one is going to give you about the liquids, and the last one about the gas. So you can see the difference. Similarly, if we talk about the shear forces, so a very, you can say, a clear boundary line exists for the solid and the fluids. So you can see that you can retain your if the static deflections be there, still your solids can retain its structure, okay, its shape. And if you are going to be draw the deflection in the form of Mohr circle, mean if it is going to be have a shear stresses or not. If you are going to apply the forces, then if internal body can resist applied forces, it is due to the shear stresses produced within the body. So if the body can resist, it's mean that it has a shear stresses. But if it cannot resist, mean the shear stresses are zero. So you can see that a certain value of the shear stress on the vertical axis exists for the solids, but on the other side, on the right hand side in the D figure, you can see that zero shear stress exists for the fluids. In the next slide, you will see the comparison of the liquids versus gases. Okay, so specifically almost the same, you can say, the points will be the same, but now we will discuss about the differences. Okay, so you can read it by yourself. These points are almost same and very general. Yes, dimension analysis. This also you have done in your preliminary classes in metric or in FSE. So now you just review your mind, you review your knowledge about the dimension analysis. So what dimensions are and what unit is. Dimension is the measure by which a physical variable is expressed quantitatively. But what unit is, a unit is a particular way of attaching a number to the quantitative dimension. So if quantitatively you are going to be measure any kind of the physical object or the physical variable, then we can say it is a dimension. But if you are going to give a number to a certain dimension, then we can say it is a unit. So this length is a dimension that is associated with such variables such as distance, displacement, width, deflection, and height, while centimeters or meters are both numerical units for expressing the lengths. So that you must be know. These primary dimensions are with you: your force, your masses, your lengths, and your time. Then if any formula is with you with the combination of these primary dimensions, then these secondary dimensions starting from area till this next slide, surface tension. For both, what you need to do, you need to just derive these secondary dimensions from the primary dimensions on a one page one by one, and then you need to just submit it by the end of the mid semester. Keep your all assignments with you, and then you need to submit at the end of your mid. Now, next slide is about the standard prefixes in SIs units. You all must familiar with that. Just I have enlisted it to review your knowledge. Okay, so tera, giga, mega, kilo, hecto, deca, deci, centi, milli, micro, nano, pico. Okay, so all of these are listed. So what is the multiple of that? 1 meter. Then you must know about that, and so that you are, if you are going to be converting the systems, so you must know about that. Okay, so